In this low-code feature focus video, I'm going to talk about using automation, which is also known as the DNN Sharp Scheduler. In this video, I'm going to start from scratch with PlantinApp, create an entity to hold some data, and then use Sharp Scheduler to keep it updated. It's going to be an interesting use case because I'm pulling the data from a weather API. So let's get started. First, I'm going to go into configuration and create my entity. The entity that I'm going to create is going to be called city or cities, and I'm going to select an icon. The entity is only going to have a few properties. It's going to have one called name, another called city code, and finally one called weather data. We'll make name be the property that we'll keep up with and display, and we'll save that. So now when we look, we have cities. We can add a new city, and we'll add Dallas, Texas. The city code is Dallas, Texas, and we're going to leave the weather data blank. The automation that we're going to put into place is to automatically keep the weather data up to date. The weather data I've selected is the openweathermap.org, which allows you to query for a city name and get a weather response in JSON format. I've already signed up for an API key and tested with the URL to determine that I can get the data back and what it looks like. This is the data that I'm going to automatically keep up to date in my weather data column. With this entity in place, we're all set to retrieve the weather data, and I'm going to do that through automation. So we'll start with that. In the configuration section, we'll see automation. The opening screen shows us the settings, the status, and the jobs, and I don't have any jobs defined yet. So this will be a new job. The job name is going to be retrieve weather information. I'm going to choose that the portal where this job works is low code, no code, and that all the work that this job does is going to be done under my user ID. The next section of automation is triggers, how often the job is going to fire. Once we get this job going, we'll fire the trigger once every minute. For now, we'll not define a trigger and only run the job manually. The next section is the main definition of the automation. What do you want the automation to do every time it fires? In our case, we want to go out and get the weather data for all of our cities, so we'll need to load all of our cities in. We'll do that by a read action. Read all cities. So we'll start by adding a description. When the cities are read, they'll be put into this output token. We need to convert this to an entity list. So we'll use a load entities JSON to do that. We're going to create an entity list from our cities. The entity model for that is going to be city:JSON. The output of that, the entity that's going to be created, is city list. We can now iterate over the city list using an execute actions. We'll enter a description, loop through all cities on the city list and get the weather data. The entity that we're going to loop through is city list. The first action that we want to take place for each city is to do a server call to get the data. So we'll do a server request, get the data for the current server, and now we provide the input parameters. When I tested through the browser earlier, I got the basic outline of how to call the weather map, but instead of using a hard-coded Dallas, we'll use the value from our city entity. The entity is city list. So we'll enter city list city code, which is the name that we assign the code that needs to be retrieved. Finally, this API requires an API ID, so we're going to need to get that. To make my app more maintainable, I've actually created a token for that in the Open Weather Map space called App ID, And I'm just going to copy that token and use it. This token resolves to the app ID that was assigned to me by openweathermap.org. We return to our automation, edit our job that we saved, find where we left off, the server request, and we'll add that token to the end of the request. We don't need to pass any data to this, and we'll say that this is a GET type request. We're going to put the output of this into a token. The token's name will be weather data. So scrolling back up, I'm going to close the server request. We should now have gotten the data from the server, and we want to store it in our entity. We'll add an action to partially update the city. The city ID that we're going to update is from city list, and it's going to be the city list ID that we update. The property that we're going to update is the weather data, and we're going to assign it the value of weather data, which was the output from our server request. And that should be it. Let's test it out. I'll save the job, open it up, and run it now. It said that it ran and had a failure. Let's see if we can figure that out. It turns out that the code for our city was not correct, so we'll edit that. The correct code for this interface is Dallas US, and so we'll update, go back to automation, and run the job again. When we investigate the failure again, we found out that string or binary data would be truncated. That means the field that we assign to it isn't long enough to hold the data. We need to change the property of the weather data from text to large text. Unfortunately, the interface doesn't allow us to change that, so we'll delete it and save the result, and then add weather data back. Since this column was empty, we'll be able to do that without any extra effort. We now add that as a large text and save. Let's try our automation again. We open the job and run it now. This time we get a success message, so let's look at our data. When we look at Dallas, Texas, we now see that the weather data has a full JSON payload. This information is readable, but not very usable. But in this video, we're not going to unpack the JSON. Instead, we're going to continue to focus on the automation. Let's add a few more cities. We'll add New York and also San Francisco. If our automation is correctly set up, we should be able to activate the job and get the weather data for all of our cities. The job ran in just over 1/10 of a second. Let's see what we have now. Now each of our cities listed have weather data. This job has been set up so that if we run it manually, we'll get all of our cities updated. Now let's dig into triggers. If we open up the automation and edit our job, we can add a trigger. This trigger is going to be a time-based trigger that's going to repeat on interval. We'll set it up to trigger once every minute. And save. Now when we look at the retrieve weather information job, we see that the next run is scheduled for 6:18 p.m. We could continue to click run it now to get it to happen immediately, but we'll just wait for 6:18 and let the job run automatically. At 6:18, the job ran automatically, again in 1/10 of a second, and it scheduled the job to run again at 6:19. This is the power of automation. This job will now run continuously and keep the weather information for these cities up to date and any cities that we add. For example, if we go back to the cities and add a new city, like New Orleans, all we have to do is wait for another minute to pass by, and this will be updated automatically. Let's watch it run. We return to the automation. Watch it flip over at 6:19. The job runs again. And now we can go look at the result. New Orleans has weather data. Before we end this video, let's take a look at some of the other kinds of automations that you can add. If we edit our job just to look, we can see that there are other types of triggers. For example, every time our app starts or ends, or every time a request is made, or when the app goes completely idle, you can trigger events. A category that I find more useful is the database triggers. These triggers run when the database changes, either when a record is inserted, a record is updated, or a particular column is updated, or even when a record is deleted. There's particular power, for example, with on-database insert, where every time a record is inserted, our trigger runs. This could be useful, for example, in getting the weather data immediately when a new record is added to the system. There are many options available for time-based triggers, for example, to run the trigger on a particular day of the week, or to specify an advanced cron trigger. Finally, we have user events, where every time a new user is created or that is logged in, you can trigger actions. You can have any number of triggers, so you can set your automation up to run in a variety of scenarios. As a final note, there is an on error section. These are actions that will run when errors are encountered within your automation. So for example, you could send an email letting the administrator know that an error happened during the job, giving the information necessary so that the automation can be repaired. So that's it. In this video, we defined an entity to hold our weather data and then defined an automation to retrieve it. This has demonstrated the power of the automation or Sharp Scheduler tool, as well as retrieving data from a remote source using the server request option. We hope this video has given you some insight into how you can use automation to automate tasks within your application. Is there some feature you'd like to see in our next video? Leave a comment in the section below. For more great low-code content, be sure to subscribe to Plant an App.